Okay, so we're going to geek it out about satellites and machine learning in a bit, but first I wanted to talk a bit about the problem we're trying to solve as it pertains to financial markets. So agricultural marketplaces were born in Sumeria 7,000 years ago, so I guess you could say that ag commodities are humanity's oldest asset class. Ag markets were a big deal then, and they're a massive deal now. The size of the global food and agribusiness industry is roughly $5 trillion. In the US, corn and soy alone had a direct farm cash value of $100 billion and roughly 15 times that in futures markets. Now, despite the fact that the supply side for ag plays out in plain view on farms all around the world, market intelligence is still driven largely by gut instinct, phone calls with farmers, and weather-only forecasts. And the result is one of the most volatile asset classes in the global economy. Now, we can do better. And last spring, two remote sensing scientists, David and Mark, set out to do just that by applying decades of experience working with NASA and the Fortune 500 to agriculture. Now, commodities traders and researchers take a lot into account when they're making decisions or recommendations based on grains, but by far the most important source of variation is crop yield. How many bushels of a crop is an individual acre of farmland going to generate? It's an incredibly important number, and the name of the game in these markets is how soon do you know, how sure are you? Now, this past January, the USDA announced that each of the 82.7 million acres of US farmland devoted to soy yielded 52.1 bushels of beans. So this is the number that the markets spent the year trying to predict and fold into their investment decisions. Every month, the USDA comes out with a monthly forecast of what that number in January is going to be. These reports get noticed. Within minutes, the market trades dramatically, driving hundreds of millions in fluctuation. And they're the highest volume trading days of the whole year. Now here are TellusLabs' forecast of that same 52.1 number. Not only did our October forecast, the last one we made in the year, land exactly on that 52.1 number that was confirmed a couple months later, but we closed within 1% of it in September. So if you were one of the 600 beta participants receiving our forecast every day in your inbox, you had 2 months of advantage on the rest of the market. Very quickly on how we do it, we start with data from satellites. Spaceborne imagery is not new to the financial sector. In fact, companies have been using high-res imagery for years to count cars in parking lots or monitor oil reserves. What we do is different. We're not expecting a couple hundred sites or counting things. We are building daily cadence planetary scale models of, in this case, all 170 million acres of US corn and soy. We're working with Earth observations coming from satellites that have been orbiting the planet for the last 15 years. And that adds up to several quadrillion data points. Now we start with a massive database of Earth observations from satellites, weather observatories, and ground stations, and we put that in our Earth database. We then get to work building features, rather. So practical, science-grade, physically meaningful vital signs for the Earth. The data scientists in the audience will appreciate the value of feature engineering. Strong features make for strong models. Then and only then do we apply modern machine learning techniques to develop the sort of predictive models that give the results we just saw. So this is what's going on under the hood. This is a demo day, so let's look at a product. Last year, 600 growers and traders signed up for our beta and received this, a daily PDF created by hand with care by David himself every morning. This year, we have developed an immersive web app alongside an intuitive API. So in order to allow our users to make better decisions, we need to arm them with context. The why matters as much as the what. Here, users can see that beyond having the answer, even if it's the right answer, they get more. They get to look at confidence intervals. They get to make historical comparisons. They can drill down to individual states or even individual counties and evaluate how much forecasts are influenced by satellite data, weather data, or ground observations. Via our new API, users can bring in all the features and all the insights of kernel into their own systems and models on their own terms. Now, getting the right answer for ags means going far afield of Iowa and Indiana. What you're looking at now is the first of its kind daily forecast based on satellite data for Argentinian soy. This is an incredibly important region for the global ag markets. In fact, right now, half of the global production of soy is in the ground in Argentina and Brazil. Now, it's an incredibly difficult part of the world for markets due to opaque reporting, intense weather events like this flooding we were tracking in La Pampas, and complex cropping cycles. That fuels an order of magnitude more uncertainty than we have here in the US. Now, I'm sure imaginations are running wild with other applications for satellite data and predictive modeling. We've already started R&D work in energy, forestry, and water resources, and over time, we'll have something to say about each of these things. We're looking for problems that are large in scale, feature data sets that are fast changing, and that have a high impact on markets and society. So here's where you come in. We've already been surprised by what expert practitioners can do when armed with these insights, and we are excited to see where this technology can take you. This year is all about working with a small group of the smartest market participants we can find, and which is why we're incredibly grateful to the FinTech Sandbox for the opportunity to speak in this forum, and to the CME Group for their support. So we are TellusLabs, and we're looking forward to working with you. Thanks.